So we are in the microscopy laboratory of the School of History, Archaeology, and Religion. Here we have our research microscope. So we do a lot of materials analysis, both for archaeology and for conservation. Our bioarchaeological students use this a lot for bone samples and shell analysis, and our conservation students use it a lot for materials identification, so they know the best way to proceed on a treatment or a stabilizing conservation plan for their objects. So here we have a wood sample that's actually up on the screen. Our students will actually have to do wood analysis because the type of conservation treatment that they use will often depend on what type of wood it is. So in order to best conserve a historical piece of wood, if it's from a shipwreck or if it's from a Roman villa, they have to identify what type of wood it is. And also our archaeologists want to do dendrochronology work on some of the samples they find from archaeological sites, and so they'd use this microscope setup to identify that.
Okay, this is our climate simulation laboratory. We have a range of equipment here that we use to understand materials. So we've got a range of climatic chambers, for example, where we can manipulate environmental conditions such as humidity, temperature, and light. And we can use this to examine materials and how they interact with the environment. We've also got reflectance transformation imaging, where we can look at the shape and surface textures of materials. And that reveals information that we normally can't see with traditional photography. And normally we detect things that we can't see with the naked eye. We've also got infrared spectroscopy, which is what we've got here. Infrared spectroscopy is a really useful equipment that undergraduates and postgraduates use daily in the laboratories to understand what objects they were working with. So what materials they are working with, what materials are within the object, what has it been treated with before, for example. And you can also detect changes in materials. Understanding all of this is really important to devise a conservation strategy, and it will inform your decision-making around treatment of an object. So to look closer at the infrared spectrometer, I've set up a sample using an aged adhesive from a ceramic plate. The infrared light source within this bit of equipment is able to generate very specific peaks. These peaks are characteristic for the material that we're looking at and can detect any changes in the material. So anything that's happened due to degradation will be seen in the spectrum. So we can compare the generated spectra to databases. And that's really useful to quickly identify what we are working with, and it can be your starting point for more manual analysis of the spectrum to try to identify what it is that you are working with.